A car drives off of a 50-meter tall cliff and lands 40 meters from the base of the cliff. That's a rather unlucky driver. How fast was the car moving?
Draw a picture!
Here is my picture. This is hopefully what all your pictures should look like for these kind of problems. So right off the bat, I'm just going to call the ground 0, y equals 0. Boom.
2. Label your nose. Your knowns. Label your knowns.
What does the problem tell me? Okay, it says a car drives off a 50-meter tall cliff. That means that the height of this cliff is 50 meters, which means that the starting height, or y naught, is equal to 50 meters. If this is my starting height, what's my final height? Well, the car ends up falling to the ground. So the car ends up getting to the ground, and we said the ground is 0. So the final height, y final, is also equal to 0. 0 meters. A car lands 40 meters from the base of the cliff. What's that saying? The box travels a distance of 40 meters horizontally. So if I'm measuring a distance, I need a starting point to start measuring that distance from. So before I tackle the final horizontal position, I'm going to tackle the initial horizontal position. So my starting horizontal position is x naught. Right? This is where it starts horizontally. And that's my starting point, so I'm just going to call it 0. 0 meters. So now I have a starting point somewhere to start measuring my distance, and it says that it lands 40 meters from the base of the cliff, or where it started. So my final horizontal position, x final, is 40 meters. And that's all we know from the problem, right? I can start solving? Ooh. No, there are actually some things that we know that doesn't tell us explicitly in the problem, but we have to extract it from the problem and write it down. We know some stuff about acceleration. Let's talk about horizontal acceleration first. We said that as an object is flying through the air, the horizontal acceleration is equal to 0 meters per second squared. There's nothing changing the motion in the horizontal direction. The problem's never going to tell you that. But you have to know that because we're on Earth and the only force acting on the car is gravity, and gravity is acting downwards, then the horizontal acceleration is 0. Do we know the vertical acceleration? Yeah, it doesn't tell us in the problem, but because we have something falling to the ground on Earth, we know that the vertical acceleration is negative 10 meters per second squared. Make sure you don't forget that negative because the acceleration is downwards, right? So it is a negative 10 meters per second squared because gravity acts downwards. Okay, now there's one more thing that we know that's very common to forget, but you need to write this fact down. This is your key to solving this question. And that is the initial vertical speed, v naught y. The instant that the car leaves the cliff, it is moving only horizontally. It has no vertical speed at the beginning. So my v naught y is 0 meters per second. It will never ever tell you that in the problem, but if you have something launched horizontally off a cliff, no angles, right, just horizontally, then your starting vertical speed is 0 meters per second. And you gotta write that down because you're gonna use it. Alright, now I've labeled everything that I know. So that's the key, is we just added 3 things that we know that wasn't explicitly told to us in the problem. So before you accelerate into finding an equation, think about the acceleration of the object and write it down. Okay, now what's my target? What's the problem asking me to find? The problem says, how fast was the car moving? So that's asking us for how fast was the car moving when it left the cliff. What was its initial speed? Is that initial vertical speed or initial horizontal speed? Well, when the car's moving off the cliff, it only has a horizontal speed. So what we're really looking for is the initial horizontal speed. That is our target. V naught x is our question mark. V naught x is that horizontal arrow to the right, initial horizontal speed. Before we choose an equation,
Because our acceleration in the x direction is 0, I want to show you what's going to happen if you plug in that 0. So if I plug in ax equals 0 for the first equation, I get vx equals v naught x. That's a true statement. We're saying that the final horizontal speed equals the initial horizontal speed. That's not wrong, but is that going to help me solve for anything? No.
Because the acceleration is 0, that whole term cancels out and gets rid of all the variables in the equation.
This is just saying that the speed doesn't change, which is true because we have 0 acceleration. The third equation, if I plug in 0 for acceleration, all of this goes away, and again I get that the final speed squared is equal to the initial speed squared, and if I square root both sides, I get again that the final horizontal speed equals the initial horizontal speed. So again, because our acceleration is 0, the third equation isn't going to help us. It's going to give us a true statement, but it's not going to help us solve for anything. So my only option is the second equation. So if I plug in a equals 0 to the second equation, I get x equals x naught plus v. I hope you didn't notice that, but I had a mistake in the second equation here. This should have been a v naught x times a time. My apologies. So I can't use the first equation, I can't use the third equation. I'm left with the second equation. And so when I plugged in 0 for my acceleration, this is what I'm left with. So let me just rewrite that down here. So this is the equation I'm going to have to use.
Again, my only options were equations where I used x stuff because I can't mix x and y stuff together. So if my target is a horizontal speed, I can only use an equation with x stuff in it.
If I go back to my problem, I know a starting horizontal position, I know a final horizontal position. I'm looking for v naught x, that's my target, but I don't know the time. Can I solve for the initial horizontal speed if I don't know the time? Well, no, because I'm forced to use this equation. The other ones won't help me solve anything. So I have to use this equation, but v naught x is my target. That's what I'm looking for. If I also don't know the time, I have two unknown things in one equation. If you have two unknown things, you can't solve for them using one equation. You're going to have to use two equations.
So this is actually a two-step problem. So I want to find the time first. And then once I find the time that the object spends in the air, then I'm going to use that time to solve for the initial horizontal speed. I'm going to solve for time. So really my target for step 1 is t equals question. Because I need the time to get the actual thing that I'm looking for. I need the time to find initial horizontal speed. So how can I find the time? I can't use x stuff. I don't know enough x stuff to find time that way. So because time is the same for x and y stuff, I'm going to use y stuff to find the time because I'll be able to find the time using y stuff. And I'm going to use that same time that I solved for with x stuff to find the initial horizontal speed. So I'm going to use the second equation with y stuff because I don't know a final vertical speed. And this equation doesn't have a v final in it. Y equals y naught plus v naught yt plus 1/2 at squared. Next step is to plug in my zeros. Do I have any zeros to plug in? I do. My initial vertical speed is 0 meters per second. So this entire term goes away because 0 times anything is 0. And my final height, my y final, is also 0. That also goes away. So I'm going to rewrite this. 0 equals y naught plus 1/2 at squared. So that made my equation look a lot nicer. My next step is to isolate the variable. In this case, I'm looking for time, t, so I need to get t by itself. I subtract y naught on both sides. I multiply by 2. Then I divide by a. So you might think this is where you stop, but we have t squared. We need just t. So to get rid of t squared, I got to square root both sides, and I get that t is equal to the root of -2y0 over a. Okay, now I'm free to plug in my numbers. So t equals the root of -2 times the starting height, which is 50 meters, so times 50 over the acceleration, and oh my goodness, I forgot to put an a sub y. Why did I do that? For all of these accelerations. What a terrible thing to do. So because we're talking about vertical stuff, this should have been an a sub y, a vertical acceleration the entire time. My mistake, sorry. And my vertical acceleration is -10. Okay, so make sure you don't leave that negative out. You want that negative there. And so these two negatives cancel to make a positive. So you get t is the root of 2 times 50 is 100, divided by 10 is 10. So the answer for your time should be root 10. So I'm going to rewrite my answer. That is not my final answer. I need units. So give me a second so I can think about this. My units are seconds. This is a time. Now, is this reasonable? Does this make sense? We're saying that it took root 10 seconds for the object to hit the ground. 10 is really close to 9, so if you know the root of 9 is 3, the root of 10 is going to be close to 3, so like 3.1 or 3.2. So 3.2 seconds, that makes sense. If you got like 0.003 seconds, it's like something way small or something way big, like a million seconds, then you should double check your work. Or if you got a negative time, also check your work because time can only be positive. But this looks good, and I guess you don't even have to present that answer because we're not really looking for the time. That's not what the problem asks us. We just needed to find the time to use it to find our actual target that we're looking for. But just boxing it honestly even helps me to go back and find it. So, part 2. Now I'm going to solve for the initial horizontal speed. So I solve for time. Now I can use that in my list of knowns. So I can add time to the things that I know. I now know that the time is equal to root 10 seconds. Whoop. Because I have to plug in the time, I'm just going to rewrite root 10 as 3.2 just because it looks nicer too. So I have my picture. I added something to my list of knowns, the time. My new target is the initial horizontal speed. Dun dun dun, find an equation. Which one do I want to use? Well, earlier in the video, we decided that we have to use the second equation for x stuff, because everything else cancels out in the other equations. This is a horizontal acceleration. Everything is horizontal. So, do I have any zeros to plug in? Well, x0 is 0. Bloop. And there's one more thing that's 0. The horizontal acceleration. That gets rid of this entire term. 0 times anything is 0. So all of that goes away, and I'm left with x equals v naught x times t. My target is v naught x, so I need to isolate v naught x. So I divide by t on both sides, so that v naught x is equal to x over t. So I guess I should have called this x an x final. Right, this is my final horizontal position. And now I'm free to plug in my numbers. V naught x is equal to the final horizontal position, 40, divided by the time, which is 3.2. And when you plug that in, you get 12.5 meters per second. Don't forget those units. This is a speed, so our units are meters per second. Is that reasonable? Yeah, that's reasonable. It's positive. It was moving in the positive direction at the beginning. There's nothing strange about that answer, so I'm cool with that. I'm going to write it out. And I'm going to box it so the grader can find it. Boom shakalaka. The way we solve this problem is going to come up a lot. So a lot of times, if they ask you for something in the horizontal direction, so like horizontal speed or maybe the horizontal distance or something like that, in order to find that stuff, you're going to need to know the time. And you're not going to know the time, so you're going to have to solve for time. And the way you solve for time is by using y stuff. So you can use y stuff to solve for time and then use that same time for x stuff to find what you need.